You use it, I use it, we pretty much all rely on it. But have you ever stopped to think about what's actually going on behind the scenes of Google Drive? Well, today we're going to pull back the curtain and unpack the incredible engineering behind this tool you probably use every single day. I mean, this is the big one, right? This is the billion-dollar question. It's not just about storing stuff. It's about building a fortress that guarantees absolute bulletproof reliability for millions of people. So how in the world do you actually do that? Okay, to wrap your head around the scale here, just look at this number, 500 petabytes. That's a rough estimate for about 50 million users. That's 500,000 terabytes. The number is it's mind-boggling. It's a mountain of data. So yeah, that number, that massive number right there, it basically dictates every single decision we're about to talk about. Everything flows from solving this one fundamental challenge, how to manage a constantly growing mountain of data. And look, it's not just about storing files in a big digital box. The system has to deliver on these core promises we all expect. You need to upload and download, of course. But the real magic is that instant sync across your phone and laptop, right? Or seeing old versions of a file, sharing with a friend, getting those little notifications. The design has to handle all of this for everyone all at once. So where do you even start? Well, with a problem that huge, you don't try to boil the ocean. You start small. You start with the absolute simplest thing that could possibly work. You put everything on one single server. Picture it, right? Just one computer in a data center somewhere, a single box. It's handling the website, it's running the database that keeps track of everything, and it's got a bunch of hard drives inside it, storing all the actual files. Simple. And you know what? For a little while, it actually works. And then, boom, you hit the wall, hard. This is the alert that tells you your simple little system is about to completely fall over. People can't upload, the whole thing is grinding to a halt. This is the moment that forces you to evolve. So it's time to level up. It's time to graduate from that one server setup and build a real architecture, one that can actually handle millions of users without breaking a sweat. It's time to scale. And this is how it's done. Step 1, you fix the storage problem. You move the actual files, the big, chunky data, to a dedicated cloud storage service. Next, to handle all the people trying to connect, you add a traffic cop called a load balancer. Then, you pull the database out into its own separate server. This database is like a library's card catalog. It doesn't hold the books, it just knows where they are and who owns them. Super important. And once you do all that, you can just keep adding more and more web servers whenever you need them. Each piece solves a specific problem. And let's just pause on that first step for a second, because it is an absolute game changer. Using something like Amazon S3 is like trading in your tiny full hard drive for a magical one that is basically bottomless. It's built for this exact problem, offering reliability and scale you just couldn't build yourself. So what's the big takeaway here? The system is no longer this one single thing that can break. All the pieces, the web servers, the database, the file storage, are now separate. They're decoupled. This design is strong, it's flexible, and it's finally ready for the big leagues. Okay, so we've solved the where do we put all this stuff problem, but what about one of the most magical features, that seamless synchronization? Well, that opens up a whole new can of worms. Here's the classic headache. Two people are working on the same shared file. User 1 makes a change and hits save. A few seconds later, user 2, who had the file open at the same time, also makes a change and hits save. The server gets the first version, so what happens to the second person's work? Does it just get erased forever? No way! The system is way too smart for that. It takes the first version it gets, sure, but when the second one comes in, it immediately spots the conflict. It then goes back to user 2 and says, whoa, hang on. Here's the version on the server, and here's the version you just saved. What do you want to do? You can pick one or merge them. No data is ever lost. It's that simple. All right, so the system is big, and it doesn't lose your work in a conflict. But how do they make it fast and efficient? I mean, this is the stuff that saves you from burning through your phone's data plan just to make a small change to a file. So imagine you've got this giant 100 megabyte file. You open it up, and you spot one little typo. You fix it. Now, the dumb way to handle this would be to re-upload the entire 100 megabyte file again, just for one tiny change. Insanely slow and a total waste of data. But here's where the real genius comes in. It's a trick called delta sync. The system is smart enough to break the file into little blocks. It sees that you only changed one of those blocks. So instead of sending 100 megabytes, it sends only the tiny 1 kilobyte piece that actually changed. This is literally thousands of times more efficient. And it's why syncing feels so instant. And the smart tricks just keep on coming. They also compress the data to shrink it down. If 1,000 people upload the exact same file, they only store one copy of it. That's deduplication. And for those old files you haven't touched in years, they get moved to cheaper, slower cold storage to save a ton of money. All right, last but definitely not least, we have to talk about the biggest promise of all. Never, ever losing your data. This means the system has to be built from the ground up to survive pretty much any disaster you can think of. So let's play a little game of what if. What if one of the many web servers just dies? A little puff of smoke and it's offline. What do you, the user, experience? The answer? Absolutely nothing. You notice nothing at all. That load balancer we talked about, its whole job is to see that failure happen and, in a split second, just send your request to a different, healthy server. The system heals itself before you even know there was a problem. Okay, let's make it harder. What if it's not just one server? What if an entire data center, a whole building in, say, Virginia, goes completely dark because of a hurricane? Are your vacation photos gone for good? And this, right here, is the ultimate safety net. Your files don't just live in one place. They are copied, replicated across multiple, geographically separate regions. So if the entire East Coast facility goes down, the system just shrugs and says, no problem, I'll just grab the copy I have saved on the West Coast. This is how they do it. This is how they can make that promise. So after seeing all of this incredible complex stance of load balancers and delta syncs and geographic replication, does it maybe change how you think about that simple little click? The next time you just casually hit save, remember all the invisible machinery that whirs to life to make sure it just works. Pretty amazing when you think about it.